Our next speaker is Professor Geert Molenberghs. He's from the University of Hasselt. He's a biostatistician, and he has published a lot on clinical trials, longitudinal and categorical data analysis, and a non-response bias. Non-response issues, sorry. Professor Molenberghs is an internationally awarded lecturer in biostatistics, and from my own experience as a statistics teacher, I know that's an outstanding achievement. Today, Geert Molenberghs is going to shed some light on hardcore methodology with an emphasis on specific statistical problems that can occur when doing research. Geert.
Thank you very much. All right. So, I'll make a few remarks from the position of a statistician, and we could actually ask with the question, where does statistics stand here? Is it a science like many other sciences? So, yes, unfortunately, there are integrity problems, but they're not more or not less than elsewhere. Or do we say, no, it's worse, or it's less bad? Or is it also part of the solution? I think all of that applies a little bit. Let me start by the last thing. Of course, we have had for the longest time, for example, forensic applications of statistics. We have had criminology applications of statistics. And those branches, sub-branches of statistics definitely are of use here as well. We should not forget that. But that's not where I'm going to spend most of my time. Let me start with an anecdote, something that really happened like 5 years ago. The American Medical Association, the society behind a journal like JAMA, the Journal of the American Medical Association, had a policy of reproducibility and verifiability of results, which is a good thing. And they singled out in their policy explicitly the medical statisticians, the biostatisticians, as a very important source of evil. So everything had to be checked, but the statistics especially so. Now, several societies then on our side, on the statistical side, took issue with that. Of course, nobody is against the verification of scientific integrity and policies, etc. But singling out a profession like that, many of us, I think, as persons and also as organizations felt a little bit too much. The ASA, the American Statistical Association, reacted against that by means of their president, and they were unsuccessful because their appeal was dismissed. So the International Biometric Society played it a little bit more cleverly and had a resolution go through its own council, and that was then submitted to the American Medical Association, and the policy has been balanced in the meantime. Now, is everything like that completely without ground? I think nothing more or nothing less, but there are, of course, a few things that could happen in statistics. And, of course, medical colleagues could also say a few things could happen in medicine as well. Let me highlight a few of those. In statistics, we often have the problem of the person not in the room. And by that I mean, I have an example of that here actually. You have, for example, an exposure and a disease, and that's in very general epidemiological terms what we would like to study. Let me make it concrete. Is smoking now a risk factor to lung cancer? Now, since Dolan Hill, we know it's one of the strongest epidemiological relationships. But of course, they did not find that out through a clinical trial or through a randomized experiment, if you know what I mean. They didn't say, let's make 1,000 people smoke heavily for 20 years and 1,000 people not at all, and then we will compare. That's the best way of verifying it in a certain way, from a certain principle design perspective. Of course, there are a few ethical issues with that experiment, and that's why we have epidemiological studies. But of course, then you have to make do with what you have available, with hospital registers, for example, with just the information that happens to be there. And of course, when you look at smoking, it comes as a package. There are also other things that make people different when they go from smoking to non-smoking. Or I mean, when you have a smoker and a non-smoker, they also differ in other ways. Like one will be a heavier drinker than the other. Even on average, there are relationships, positives and negatives. And that's the third kit on the table, but the one you don't see, the invisible man or woman, the confounding variable. So, of course, every good epidemiologist, every good statistician knows first, that's a very tough problem. There is no unique solution to that. You can do the best you can, but of course, the complete opposite, the worst you can, is completely forget about this issue. So, of course, if you have bad intentions, you can make use, quote unquote, of that phenomenon. And that brings us into a gray zone. Have we really corrected for what we should correct? Have we done that with the best intentions? Or perhaps no. And of course, how can we solve it? We can't solve it, but at least we can do the best we can. Like every decision that we take in this respect, make it crystal clear so that when I do something, you can reproduce my results the way I do it. And if you get something different, you or I or both of us made a mistake and we can talk about it. We can verify it further. But also, you can disagree with my methodology, and that's fine. There's no problem with that, because statistics in that sense, it's not only mathematics. Let's take the working hypothesis for now that in mathematics, usually things are clearly verifiable, it's right or wrong. And even that's not always the case, of course. You can have a theorem that's usually right for most practical purposes, but there may be that regularity condition that somebody even forgot to put in the theorem, so it's slightly wrong. It applies 95% of the cases, but for the Cauchy distribution, for example, it doesn't, because it doesn't have a finite mean. So for those people starting to sample from the Cauchy distribution, you will have a problem. But those of you sampling from the T distribution will be fine. So there is also a gray zone there. That was one example I brought forward. We can think of many others. There is the old case in the meantime, and actually still the Flemish government and many universities are following up on that. That's the relationship between environment and health. Now that's a very broad denominator, but in this country, in Flanders, it started a number of years ago with a scare with a waste incinerator that was actually exhausting a little bit of dioxin and allegedly led to congenital malformation in the people living too close to the waste incinerator. Now, you have again to be extremely careful. And why is that? Well, first, when something like this happens, there may be political connotations. There may be political issues related to a problem like that. A certain government official may want to keep that waste incinerator open at all cost because he or she is on the board of directors. Possible. Another politician may want to close it at all cost because he's not on the board of directors and he still holds a grudge over that. Now, both of them may have ulterior motives for the decision one way or another. And of course, there is also the public opinion. There are, rightly so, I think, people that are scared and worried, and perhaps too much so. That's perfectly possible, but who knows before you know what the real case is. Well, this case is about 20 years ago, and still to this day there are projects on environment and health, etc., for a very good reason. But very likely, what could have happened, well, for those people from Antwerp and from the University of Antwerp in particular, that's where it happened, because the thing was located in Wilrijk. And around that waste incinerator, there was indeed an increased risk, apparently, of congenital malformations. There were indeed a number of people living there, slightly elevated over background with problems in their babies. Now, what you can do then is look at this in a very, very, very careful way. But that's very, very difficult if the flags are out, the black flags of the groups, the politicians, etc. So what do you do? Well, ideally, like happens in many other countries, the Netherlands is a good example there, or the UK, is you should have somewhere in the drawer a protocol that's as clear and as complete and as objective as it can be. That protocol may be open for revision. But if it was written 5 years ago and there's a crisis now and I use it, at least it was not written precisely for this purpose. And that's a good thing. After this crisis, we can revise it and update it for the next time. But there is a disconnect between what we decide on the methodology now and what is going to be the consequence of the study. If the methodology is done, is constructed precisely for this particular study, it becomes a random variable. The methodology becomes a random variable, and it comes with its own sources of bias and variability. What did actually happen at the end of the day? Well, it's hard to know, but a very plausible analysis actually showed that there is another reason, another very important reason for congenital malformation, and that's in vitro fertilization. Now, as it happened, it was a fairly young, highly educated neighborhood. It's not far away from the University of Antwerp after all. People do get families a little later, and there is, of course, also the means available to make use of IVF. And actually, when that factor was taken into account, the environmental factor disappeared. So, am I working for the industry in one way or another? Well, I think it's safer not to have that exhaust. Dioxin is not something to play with. But there are other components, like cadmium, for example, that may be even worse. So we have to put things very carefully in perspective with as little a prioris as possible. But again, if you can disconnect the methodology from what you're actually having as a case, that already helps a little bit. Another study, because I mentioned cadmium, and now just to balance a little bit, I'm going randomly to another province, Limburg. In the north of Limburg, historically, there is cadmium contamination. And again, there was a worry that people living there, and that worry hasn't gone away actually, it's still there, that people exposed to that compound would be indeed prone to increased risk of lung cancer. There we go again. There is our lung cancer again. Now, if you do a long-term follow-up study, and it's a good thing to do that and study it very carefully, along with what is known from other sources. Again, as I said, objectivity of methodology is important, objectivity of sources as well. Maybe we can also learn from what happened in other parts of Europe, other parts of the world even, because that will at least add additional evidence. But back to the case, if you want to study the relationship now between cadmium and lung cancer, there is a huge confounding variable, and that's smoking, of course. Smoking is allegedly, and there is a lot of scientific evidence for that, a much stronger cause for lung cancer than is cadmium. Yeah, but smoking was the cause a moment ago. That's true, but in this particular study, no. Here, smoking is a confounder. Now, you have this huge confounder, and you're studying still an adverse effect, but a much smaller one. You have to very carefully correct for smoking. And without going too deep into the case, it's going to make a huge difference if you correct for people's smoking status at baseline, for example. You believe, you tell yourself, you tell the world in publications, in the Lancet and wherever, that there is a risk, etc. Somebody else does the study, but now corrects for the entire course of somebody's smoking status. Because if 15 years ago I was a smoker, but 5 days after the study took place I quit smoking, or rather I became an even heavier smoker over the years, that's a pretty different thing. And would that now play a role? Yes, it does, if you have a huge confounding variable and a small effect that you want to study. So am I saying cadmium, after all, is the gist of my story? Cadmium is important or not important, you should worry about it or not? No, I don't know that, and I don't want to go into that. I'm just saying you have to be extremely careful. Mistakes are easy to make innocently. And mistakes are also easy to make the other way, of course. That actually goes together. A few other things, a few other comments. We already talked to the previous speaker, and we all know about invention of data, invention of studies. Let's say that's the black situation. But what I was trying to say on the previous slide is there is a lot of gray zone, of course. A lot of very careful thinking needs to be put into there. When we move into the gray zone, we can say, okay, we have a study here, but a few subjects do not fit in with the hypothesis, we throw them out. Now, depending on the background in which you work, you say, yeah, that's what you have to do. And other people say, what? What are you doing? That's completely against, for example, the way a protocol is executed in a clinical trial. Often it depends on the culture. And that's very important. And what do I mean by culture? Everything that makes certain groups of people on certain dimensions a little different from other people. And that can be just the classical everyday culture, for example, the part of the world you come from, your gender may have an impact on that, how you think about hierarchical relationship. I know it's wrong, but my boss tells me. In certain countries, that's enough to just do the reverse, as your boss says. But in other countries, it's the other way around. And you accept authority more so than scientific integrity. Am I judging that? No, I'm just pointing to it. So there are cultural aspects that we have to be very sensitive about. And in an international context, we have to learn that a little bit. We have to be multicultural in that sense, understand how even in a field like a science like statistics, there may be very different cultures. I've had cases where I made a mistake, many, but in a few cases my PhD students knew that and didn't tell me because they thought that's not done. Whereas I couldn't see myself not doing that. If you find a mistake, you tell people, knowing that they may be upset, but it needs to be done. So it's a matter of culture, of course. And what I once had, and I will gently move towards the end there, is this equation is right. So it's not a matter of is it right or wrong. Yeah. So I mean, this equation is right. That's what I said. Now, I once did, way back when, about 20 years ago, I developed a piece of methodology, like we often do. And developing methodology, that's an interesting case because it's different from the use of statistics when the substantive question comes first. If you contribute to a medical or a psychological or a sociological study, then that comes first. But of course, there is also methodological research. So how do we go about examples then? The example is just to illustrate, right? Right? I don't know. Because I had developed a methodology, it seemed to work better than another model that existed already, because that other model I could not get to work. Yet somebody else could get it to work. Somebody in another continent, at the other side of the Atlantic Ocean, not to be precise, got it to work and even got much more significant results than I did. We both worked with a similar situation, a similar type of study. It was a primary dysmenorrhea study, 3 repeated measures, a crossover trial. And I had one with only 243 patients, but his study was very similar, but happened to have 729 patients, until one day I realized all of a sudden that that's 3 times 243. So what had happened? The person had simply tripled the study to illustrate. Now, I think that's a poor choice enough if you tell people, but at least then you tell people. But it was nowhere to be found in the study. I engaged in a discussion with the person, and he embarrassed said that he had indeed tripled the study and therefore got the numerical analysis to work. The convergence worked, whereas for 243 it didn't. Now, if he would have said, it doesn't work on 243, but just for the sake of argument, if we triple it for that sample size, it works, he would have known something, I would have known something that would have been a little more variable. But these are simple examples of how the pressure goes. And then to round off, the SOLAS example, in missing data, we all know that Don Rubin is a huge authority. And I'll say something about him. I'll mention a name, but I won't judge. Now, he has developed multiple imputation as one of the techniques that we often use, and SOLAS was one of the first standalone packages that did that stuff. In the meantime, you can do it with R, with SAS, and so on and so forth. And he once told me that SOLAS is the best way for doing it, but he happens to be on the board of directors. Now, I don't trust that answer anymore. And I'm not saying it's wrong, I'm not saying it's right, I'm saying I don't want to hear his opinion on that anymore. Because I would like to, and I want to hear his opinion on very many other things, be sure of that, and listen to it. But on that aspect, his opinion to me is of no value anymore because he has a conflict of interest. And that's fine. It's fine to have conflicts of interest, but at least declare them. He did declare it, that's no problem. He didn't try to hide, he's actually proud of his membership of the board of SOLAS. But if they're on the table, you and I can think about it, we can come to a conclusion that we trust that information, yes or no. Maybe you disagree with me and say, after all, what Ruben says, even in a case like this, I think it's important. Fine, we can then agree to disagree, but at least all the playing cards are on the table. So I think we should try and do that as much as we can. Thank you.